Hi everyone, I'm Soumya Paul and welcome back to day 4 of our DSA series. So today we'll be working on how to calculate time complexity. In the last video we saw what is time complexity and why is it important. Today we'll see how to calculate time complexity. So time complexity is calculated using something called as the big O notation. This is called as big O notation. Big O notation. So some examples, big of n, this is a time complexity, big of n square, this is a time complexity, big of n cube, this is a time complexity, big of log n, this is a time complexity, big of n log n, this is a time complexity, then big of 2 power n, this is a time complexity, big of root n, this is a time complexity. So how do we specify this? We specify this something like this: big O of some function of n, where n is what? N is our input size. N is our input size. Okay. So what does this function tell? What does this function tell us? This function tells us, how quickly the time taken by our code, how quickly the time taken by our code grows if the input grows. Okay. Don't worry, this may seem a bit confusing, but we will quickly cover this. Let's take some example. Say my time complexity is big O of n. Okay. And say the time taken by my code to run is say 100 milliseconds. Okay. Now, if my input size triples, then since my dependency is linear, my time taken will also triple. If my input triples, if my input becomes 3n, my time taken by the code will also be 300 milliseconds. Similarly, if the time complexity is say big O of n square, and this program also takes 100 milliseconds to run, then if my input size triples, so what will happen? If my input size triples, then the square of it will be 9n square. So in a way, my time taken will not triple. My time taken will now be 9 times. Okay, so this will become 900 milliseconds. So this is what time complexity tells us. This is exactly what time complexity tells us. Okay. By changing the input size, how linearly or how fast the number of operations increases. And based on the number of operations increasing, my time will also correspondingly increase. Okay, let's quickly take some code examples. Okay, so here, take a look at, let's say we have an array of length n. Okay, n is the length of the array. And here, this is my for loop. How many operations are there? Whenever you have to calculate time complexity, this is a very, very frequently asked question. No matter whichever company you are applying for, if it is a good product-based company, and if they have given you a lead code based DSA question, then once you solve the question, they will ask you what is the time complexity of this code. So you should know how to calculate time complexities. Okay, so to calculate time complexities, what you need to do is kind of calculate number of operations. So here you see, in a for loop, how many operations are there? Your I is going from 0 to n minus 1. So that means there are n operations. So if there are n operations, that means this for loop is running for n times. If this for loop is running for n times, its time complexity is big O of n. Its time complexity is big O of n. Okay. Suppose you have a nested for loop. So what I'll say is, when you have a for loop, what will be the time complexity? In a for loop, the time complexity will be number of operations or number of times the for loop runs is the time complexity. Okay, is the time complexity. If you have one for loop, okay. Suppose you have a nested for loop. If you have a nested for loop, suppose you have two for loops. Okay, you have an outer for loop and you have an inner for loop. Then the total time complexity will be time complexity of outer loop into time complexity of inner loop. Okay, this. Okay, so what will it be? The time complexity of outer loop is big of n, because this is going n times. It is having n operations. Similarly, the inner loop is also going n times. It is also having n operations. So the outer loop will have big of n time complexity. The inner loop will also have big of n time complexity. So the total time complexity becomes the multiplication of that, which is big of n, which is big of n into big of n, which becomes big of n square. Okay, this is what the time complexity becomes. Okay, now suppose you have this for loop. What do you think? Again, same thing, count the number of operations. You see here I is going from 0 to n, but that doesn't mean that the for loop is running for n times. No, because see the increment is happening in multiples of 2. So I is going from 0 to n. Sorry, it should not be 0, it should be 1. Otherwise it will always keep on staying 0. It is going from 1 to n, and I is incrementing by I into 2. So first we have 1, then 2, then 4, then 8, 16, until we reach n. Okay. So what we are doing is we are multiplying it by 2. Okay, we are multiplying it by 2. So there will be some 2 power I which is less than equal to n. And this I is the number of, suppose let's say, okay, let's understand it like this. Suppose this for loop ran for k times. Okay, let's say this for loop ran for k times. Okay, if this for loop is running for k times, how do I find out what k is? You see, this for loop will run till I is less than n, Okay, so if for loop ran for k times, that means when for loop runs for 1 time, I changes from 1 to 2. When for loop runs for 2 times, I changes from 2 to 4, isn't it? For loop ran once, I became 2. For loop ran twice, I became 4. For loop ran thrice, I became 8, and so on. So if for loop ran k times, I will become 2 power k, and 2 power k is less than n. Okay, 2 power k is just less than n. And it will stop because 2 power k plus 1 will be greater than n. Okay. So I'll take log on both sides, log, and here I'll take k log 2 is less than log n, and here I'll take k is less than log n by log 2. So k is less than log n base 2. So here my for loop will run at max log n base 2 times. So that is why the time complexity here becomes log n base 2. Here the time complexity becomes big of log n base 2. Okay, great. And similarly here also it is coming from n to 0, but now it is getting divided instead of multiplication, but it is the same concept. So here also time complexity will be big of log n. Okay, now suppose you have something like this. Let's say okay, you have something like this. Okay, what do you think is the time complexity of this entire for loop? What do you think? Again, as I said, if you have nested for loops, then the total time complexity will be the multiplication of time complexities of each for loop. So the time complexity of this total for loop is the time complexity of this for loop multiplied by time complexity of this for loop multiplied by time complexity of this for loop. So the time complexity of the first for loop is what? Big O of log n. The time complexity of the second for loop is what? Big O of n, because there are n operations. The time complexity of the third for loop is big O of n. So the total time complexity becomes big O of n into big O of n into big O of n into big O of log n. This becomes big O of n into log n. Okay. Great. So I hope you guys are completely clear with how to find time complexities, but still, if you want to go into much more in-depth concepts of how to find time complexities of some even more complex functions, even more complex programs for recursive codes using some complex theorems, then do join Code Cardos and keep following this series for some more interesting concepts every single day in just 5 to 10 minutes.